All right, guys, this is 12.1 part 2, the misuse of statistics. So if you haven't seen part 1, please watch that first. All right, so many individuals, businesses, and advertising firms misuse statistics to their own advantage. The reason why is because if they can make the consumer think their product is superior in any way, they're going to do it. So we're going to discuss ways in which people misuse statistics. We want to consider the following when examining any kind of statistical information given to you. Was the sample used to gather the statistical data unbiased and of sufficient size? Okay, if you have a sample size or a population that's too small, that's not really an accurate inference that you can make for the whole population. Okay, so an example that would be, let's say I took 5 of you and asked you questions about your experience at HCC, and then I said, based on what you told me, that everybody at HCC had those same experiences. Do you see how that would be a problem? Is the statistical system ambiguous? Could it be interpreted in more than one way? Sometimes little said is the best for companies, because if you say too much, you can back yourself in the corner. So if they don't say enough, you can make some kind of generalization based off the information given, but it could be taken more than one way. What is not said? So let's check out this one. 4 out of 5 dentists recommend sugarless gum for their patients who chew gum. So if we look at that, first of all, I mean, the sample size is ridiculous. It says 5 dentists, 4 out of 5. And then how about the rest of them? What other types of things do they say? Maybe they tell their patients not to chew gum at all. In this advertisement, we do not know the sample size and the number of times the experience was performed to obtain the desired result. Like I said, how many people do we actually have? The advertisement does not mention that possibly that 1 out of 100 that possibly only 1 out of 100 dentists recommend gum at all. And that's what I was saying before. So you got to be careful when you read something like this, what they're actually saying. So here's another one. In an advertisement for golf balls, a driver golf ball is hit and another brand golf ball is hit in the same manner. We are told that driver golf balls travel farther, and we are supposed to conclude that the driver golf ball is a better golf ball. So what do you guys think about that? So let's see what's not said here. The advertisement does not mention the number of times experience was previously performed or the results of the earlier experiments. The other thing is, you could have like 2 different players and maybe the other player just hits the ball harder. That's a possibility. Possible sources of bias include wind speed and direction. That's something to take in consideration. That no 2 swings are identical, and that the ball may land on a rough or smooth surface. Okay, the other thing to watch out for, besides what's not being said, is vague or ambiguous words. Vague or ambiguous words also lead to statistical misuse or misinterpretation. The word average is one such culprit. There are at least 4 different averages, some of which are discussed in section 12.3. And what they mean is, do they mean the mean, the median, or the mode? Because sometimes the word average is included when it only should be used for the mean. Each is calculated differently, and each may have a different value for the same sample. Okay, here's an example. During contract negotiations, it is not uncommon for an employer to state publicly that the average salary of its employee is $45,000, whereas the employee's union states that the average is $40,000. So what do you guys think about that? Who's lying? Actually, both sides may be telling the truth. Each side will use the average that best suits its need to present its case. Do you guys see how that works? So with statistics, do you remember the definition said it's the art of collecting data? It is not pure science sometimes. Advertisers also use the average that most enhances their products. Consumers often misinterpret this average as the one for which they are most familiar with. Another vague word is largest. For example, Harding's claims that it is the largest department store in the United States. What does that mean, largest? Does that mean size-wise? Does it mean profit? What does it mean? Does it mean largest profit, largest sales, largest building, largest staff, largest acreage, or largest number of outlets? I don't know. It's not really clear. So still another deception technique used in advertising is to state a claim for which the public may draw irrelevant conclusions. For example, a disinfectant manufacturer claims that its product kills 40,760 germs in a laboratory in 5 seconds. To prevent colds, use disinfectant A. It may well be that the germs killed in the laboratory were not related to any type of the cold germ. It didn't say it killed cold germs, it just said it killed germs. Company C claimed that its paper towels are heavier than its competitor's towel. Therefore, they will hold more water. Is weight a measure of absorbency? So you got to be careful. A rock is heavier than a sponge, yet a sponge is more absorbent. You see what I mean? So the next one is we're going to talk about draw irrelevant conclusions. An insurance advertisement claims that in Duluth, Minnesota, 212 people switched to insurance company Z. One may conclude that this company is offering something special to attract these people. What may have been omitted from the advertisement is that 450 people in Duluth, Minnesota dropped insurance company Z during the same period. This kind of reminds me of those commercials about Sprint, Verizon, and AT&T. You know, more people switch to Verizon. Well, how long do they stay? Okay. Drawing inferential conclusions. We're going to do a couple more of these. A foreign car manufacturer claims that 9 out of every 10 of its popular model car is sold in the United States during the previous 10 years were still on the road. From this statement, the public is to conclude that this foreign car is well manufactured and would last for many years. The commercial neglects to state that the model has been selling in the United States for only a few years. That's kind of funny. The manufacturer could just as well have stated that 9 out of every 10 of these cars sold in the United States in the previous 100 years were still on the road. Okay, so I got you to the point where we're at charts and graphs, so I'm going to go ahead and finish up this section. Charts and graphs can also be misleading. Even though the data is displayed correctly, adjusting the vertical scale of a graph can give a different impression. What vertical scale means is how much distance you have between each tick mark. So let's look at this first example. While each graph presents identical information, the vertical scale have been altered. If we look at stock A, you know, that looks like it's a steady increase, but not a great increase. And if you look at stock B, you're like, wow, I'm going to get that stock because it's increasing dramatically. It has a nice positive slope. But if you look closely at the tick marks, if we look right here, and I'll grab my pen so we can see this. If you look here, this is 25. If you look where this one starts, this is 25. Okay? And then we have this slot here, which is around 27. Well, that's around 27. If we look at this one here, this is 30, and this one's 30. So what they've done is they've made this one a little bit more exact by taking 25, 26, 27, 28, 29, 30. So we're doing every single number in between each value, whereas this one is in groups of 5. So this is 10, 15, 20, 25, 30, etc. So that's just 2 ways to display your data. Now, if you're the company that's selling the stock, you'd probably go and show this one to the consumer. Okay, so let's look at the next one. The graph in part A appears to show a greater increase than the graph in part B, again because of the different scale. So this scale here is 5. Do you see the difference? Whereas this one is in groups of 20. So if we look at this one, we're like, oh, 2009, 2010 went up a little bit, right? But in this scale, it's like, whoa, look at the increase we had. So if you're trying to show a greater increase, you'd want to use A. But if you're trying to show that there's very little difference, then you'd use B. Charts and graphs. Consider a claim that you have invest $1. By next year, you'll have $2. This type of claim is sometimes misrepresented. Actually, your investment has only doubled. But the area of the square on the right, if we look at it, is 4 times larger than the square on the left. If it was literally to scale, then you would do 2 times the amount. And I'm drawing on this board, so it's not great. But this is how big the other square would be, you know? So this is 2 times the size. So this is making 4. Do you see that? So I can include 4 squares, and it's the size of this one. So this is 4 times larger than this guy, and it's just showing, oh wow, look at the big increase, but it's really, you know, just twice its size. Okay, by expressing the amount as cubes, you can increase the volume 8-fold. So now this is year 1 and this is year 2. So you're like, wow, this is exciting. All right, so circle graphs, let's look at those really quick. A circle graph can be misleading if the sum of the parts of the graph doesn't add up to 100. And guys, I've seen this actually in public, so it's kind of crazy. So we look at this, we're looking here and we're looking at, oh my gosh, we have 49 here, we have 37 here, and then we have 42. Well, 49 is almost 50, and this is, you know, adding this together, it gives you almost 90, and then we have 37. So see how this exceeds 100%? That's not a very good circle graph if it does that. The graph on the previous slide is misleading since the sum of its parts is 183%. The graph other than a circle graph should have been used to display the top 6 reasons why Americans say they use the internet. So despite the examples presented in this section, you should not be left with an impression that statistics is used solely for the purpose of misleading or cheating the consumer. As stated earlier, there are many important and necessary uses of statistics. Most statistical reports are accurate and useful. You should realize, however, the importance of being an aware consumer. So basically, this section is just identifying that, hey, you know, when you're out and about and you see these grandiose claims, you know, just think about it for a moment and see if it's truly what it says it is. Sometimes it is, and, well, sometimes it isn't. That's the end of 12.1. You can go ahead and do your homework now.